Hello mga ka-learners! Together with our official hashtag Learn More, Aim High, let us continue our lessons that are aligned to the most essential learning competencies in Math 9. And in this video, you will learn the discriminant and the characteristics of the roots of quadratic equations. And our objectives are, we have the learner determines the discriminant of a quadratic equation, and the learner characterizes the roots of a quadratic equation using the discriminant. And our overview is, the discriminant is part of the quadratic formula underneath the radical sign. It is used to characterize the roots of quadratic equation in the form ax squared plus bx plus c equals 0. In quadratic formula, x equals negative b plus minus square root of b squared minus 4ac all over 2a. The value of the expression b squared minus 4ac is called the discriminant of the quadratic equation ax squared plus bx plus c equals 0. And the discriminant can be 0, a positive and perfect square, a positive but not perfect square, or negative. Here, we are talking about 0 discriminant, so meaning to say, d is equal to 0. And here, we're talking about positive numbers, so the discriminant is greater than 0. And for negative discriminant, this is d is less than 0. Alright? So how to solve or to determine the discriminant of a quadratic equation? So here are the steps. 1. The quadratic equation must be in the form ax squared plus bx plus c equals 0. If the given equation is not in standard form, so we have to transform the equation into standard form or into the form ax squared plus bx plus c equals 0. Number 2, we have to identify the values of a, b, and c. Number 3, let the formula of discriminant as d equals b squared minus 4ac. Number 4, substitute the values of a, b, and c to the formula of discriminant. Number 5, we have to simplify. Now, what are the characteristics of the roots of quadratic equations using the discriminant? So we have this. Number 1, a discriminant of 0 or d equals 0 indicates that the roots of the quadratic equation are real numbers and are equal. Again, if d equals 0, then the roots of quadratic equation are real numbers and are equal. Number 2, a discriminant of positive and perfect square, or d is greater than 0, where d is a perfect square, indicates that the roots of quadratic equation are rational numbers and are not equal. Again, if d is greater than 0, where d is a positive or where d is a perfect square, then the quadratic equation has rational numbers and not equal roots. Number 3, a discriminant of positive but not perfect square, or we have d is greater than 0, where d is not a perfect square, indicates that the roots of quadratic equation are irrational numbers and are not equal. Again, if d is greater than 0, where d is not a perfect square, then the roots of quadratic equation are irrational numbers and are not equal. Now, since we have two cases under positive discriminant or a discriminant greater than 0, we have to generalize. For case 2 and 3, if d is greater than 0, then the quadratic equation has two distinct real roots or solutions. What is distinct? Distinct means different. And take note, guys, both rational and irrational numbers belong to real numbers. So that is why we have two distinct real roots, or two different real roots. Next, number 4. A discriminant of negative or d is less than 0 indicates that the quadratic equation has no real roots. So here we can have imaginary solutions or roots to our quadratic equation. Example, letter A. Calculate the discriminant and tell the characteristics of the roots of the following quadratic equations. Let us start with number 1. X squared minus 4x plus 4 equals 0. So here, the given equation is already in standard form. So let us proceed in identifying the values of A, B, and C. And A is equal to 1, B equals negative 4, and C equals 4. Next, we have to substitute the values of A, B, and C in the equation B equals B squared minus 4AC, or into the created formula for discriminant. Next, D equals negative 4 squared minus 4 times 1 times 4. So we substitute 1, or we substitute negative 4 to B here, and we substitute 1 to A, and 4 to C. So that is why we have D equals negative 4 squared minus 4 times 1 times 4. And we have to simplify. Negative 4 squared is 16. Negative 4 times 1 times 4 is negative 16. And 16 minus 16 equals 0. So our discriminant is 0. Now, recall, what is the characteristic of the roots of the quadratic equation if the discriminant is 0? We have this. Since the discriminant is 0, we can say that the roots of the quadratic equation x squared minus 4x plus 4 equals 0 are real numbers and are equal. Again, real numbers and are equal. Let us check. To check, solve for the roots of x squared minus 4x plus 4 equals 0 using the quadratic formula. X equals negative b plus minus square root of b squared minus 4ac all over 2a. So since we already have the discriminant of 0, we will just substitute the value of, or the values of a, b, and the discriminant. So here, we substitute negative 4 to b, and we substitute the value of the discriminant, or the value of b squared minus 4ac, which is 0, and we also substitute the value of a, which is 1. So we have x equals negative 1 times negative 4 plus minus the square root of 0 all over 2 times 1. And we have to simplify. We have x equals 4 plus minus 0 all over 2. So negative 1 times negative 4 is 4, and we have to copy this, and the square root of 0 is 0. All over 2 times 1 is 2. And here we have two resulting linear equations. So we will split, or we have to separate for us to see or to solve the values of x. So we have x equals 4 plus 0 all over 2, and x equals 4 minus 0 all over 2. And let us simplify this one first. 4 plus 0 is 4 over 2, and that is 2. So x equals 2. Next, for x equals 4 minus 0 all over 2, 4 minus 0 is 0 over 2. We still have x equals 2. Now, our roots are equal. So that is meant by real numbers and are equal if the discriminant is 0. Next, number 2, we have x squared plus 7x plus 10 equals 0. So again, our quadratic equation is already in standard form. So we have to identify the values of a, b, and c. And here we have a equals 1, b equals 7, and c equals 10. Next, let us substitute the values of a, b, and c in the equation b equals b squared minus 4ac. We will just do the cycle. Next, so d equals 7 squared minus 4 times 1 times 10. So we'll just substitute the value of b here, and then the value of a, 1, and then the value of c, which is 10. And we have to simplify. 7 squared is 7 times 7, which is 49. And negative 4 times 1 is negative 4 times 10 is negative 40. So we have d equals 49 minus 40. What is 49 minus 40? We have 9. So d equals 9. And our discriminant here is greater than 0. At the same time, that is a perfect square. 9 is a perfect square. So what is the characteristic of our roots? So since the discriminant is greater than 0 and a perfect square, we can say that the roots of the quadratic equation x squared plus 7x plus 10 equals 0 are rational numbers and are not equal. So they are rational and not equal. Let us check. So to check, solve for the roots of the x squared plus 7x plus 10 equals 0 using the quadratic formula. So again, we have this quadratic formula, x equals negative b plus minus square root of b squared minus 4ac all over 2a. And we will just substitute the values of a, b, and the value of discriminant. So we have x equals negative 1 times 7. So the value of b is 7. And the value of discriminant is 9. So we have square root of 9 or plus minus square root of 9 all over 2 times 1 since the value of a is 1. Next, we have to simplify. So negative 1 times 7 is negative 7. Plus minus the square root of 9 is 3 all over 2. Again, we will separate this linear equations into two equations for us to solve the two values of x. So we have x equals negative 7 plus 3 all over 2. And the other one is x equals negative 7 minus 3 all over 2. Let us simplify first this one. We have for negative 7 plus 3 all over 2, that is negative 4 all over 2. And to simplify negative 4 over 2, that is negative 2. So x equals negative 2. Next, let us simplify this. For negative 7 minus 3 all over 2, we have negative 10 over 2. And negative 10 over 2 is negative 5. So we have x equals negative 5. So as you can see, as you can observe, the values of x are negative 2 and negative 5. They are distinct. They are different. Next. Number 3. X squared plus 6x plus 3 equals 0. So our equation is already in standard form. So let us identify the values of a, b, and c. A equals 1, b equals 6, and c equals 3. And we have to substitute into the formula of discriminant. We have d equals 6 squared minus 4 times 1 times 3. And 6 squared is 36. And negative 4 times 1 times 3 is negative 12. So we have d equals 36 minus 12. And that is d equals 24. So here, our discriminant is greater than 0, but not a perfect square. So what would be our, or what would be the characteristic of our roots? So we have, since the discriminant is greater than 0, but not a perfect square, we can say that the roots of the quadratic equation x squared plus 6x plus 3 equals 0 are irrational numbers and are not equal. Again, irrational numbers and are not equal, irrational and different. So let us check. So let us solve for the roots of x squared plus 6x plus 3 equals 0 using the quadratic formula. So let us substitute the values of a, b, and the discriminant to this formula or quadratic formula. So we have x equals negative 1 times 6 as our value of b is 6 and positive negative square root of 24 since our discriminant is 24 all over 2 times 1 since our a is 1 and we will simplify. So again, 24 is not a perfect square, but we can simplify this by looking two factors, wherein one of its factor is a perfect square, and the factors are 4 and 6. So we have the square root of 4 is 2. That is why we have x equals negative 6 plus minus 2 square root of 6 all over 2. And we have to separate these two equations, linear equations. We have x equals negative 6 plus 2 square root of 6 and x equals negative 6 minus 2 square root of 6 all over 2. Again, we have two resulting equations. So we have to separate these equations for us to solve the values of x. So we have x equals negative 6 plus 2 square root of 6 all over 2 and x equals negative 6 minus 2 all over and x equals negative 6 minus 2 square root of 6 all over 2. So we will simplify first this one. So negative 6 over 2 is negative 3. 2 over 2 is 1, so we don't need to write 1. Instead, we have 2 plus square root of 6. Next, negative 6 over 2 is negative 3, and negative 2 over 2 is negative 1. So we only have negative square root of 6. And these are now the values of x, or the roots of x squared plus 6x plus 3 equals 0. So again, since we have the presence of a radical term, which cannot be expressed as the quotient or ratio of two numbers, this is irrational. So we have irrational numbers and different or distinct, not equal. Next, number 4. We have 3x squared minus 7x plus 5 equals 0. So we have to, since our equation is already in standard form, we have to identify the values of a, b, and c. A equals 3, b equals negative 7, and c equals 5. So we have to substitute into the formula of discriminant. So we have d equals negative 7 squared minus 4 times 3 times 5. So again, the value of b is negative 7. So here, and the value of a is 3, and the value of c is 5. Simplify. Negative 7 squared is 49, and 4 times 3 times 5 is negative 60. And what is 49 minus 60? We have d equals negative 11. And this number, negative 11, is less than 0. So our discriminant here is less than 0. So what would be the characteristic of the roots of 3x squared minus 7x plus 5 equals 0? We have, since the discriminant is less than 0, we can say that the quadratic equation 3x squared minus 7x plus 5 equals 0 has no real solutions or roots. Let us check. Let us solve for the roots of 3x squared minus 7x plus 5 equals 0 using the quadratic formula. So let us substitute the values of a, b, and the discriminant. So we have x equals negative times, or negative 1 times negative 7, plus minus the square root of negative 11, or discriminant is negative 11, all over 2 times a, or times 3 as the value of a. And we have to simplify. So we have negative 1 times negative 11. So we have negative 1 times negative 7 is 7, plus minus the square root of negative 11, all over 6. So we have to separate these equations into two equations. So we have x equals 7 plus square root of negative 11 all over 6, and x equals 7 minus the square root of negative 11 all over 6. And these terms are already in simplest form. So this is now the final answer. So as you can see, we have negative radicand And this will yield us into imaginary solutions or roots. That is why we have no real solutions or roots if the discriminant is less than 0. So letter B, this is your task, guys. Determine the characteristic of the roots of the following quadratic equations using the discriminant. So number 1 to 5, we have 2x squared plus 5x plus 10 equals 0. 3x squared minus 2x minus 5 equals 0. X squared minus 7x plus 9 equals 0. X squared minus 8x plus 16 equals 0. And number 5, 4x squared plus 20x plus 25 equals 0. So, keep on solving, keep on practicing. Those things will lead you to master the lesson. Alright? So, before I will officially close, let me share this to you guys. Lead yourself and walk through the path of mastery by your very own Xermar. And again, guys, don't forget to like, subscribe, hit the bell icon, comment, and share. Thank you so much.